చేస్తారు ఏమన్నా దానికి తగ్గట్టు చెప్తారు మిగతా అది ముందైనా ఇన్ని రోజులు ఆపినాడు ఒకసారి మల్టీ పెయింట్ చేస్తే ఏమవుతుంది అది పేకు దానికి అవసరం లేదు అంటున్నాను పేరు కదా ఒరిజినల్ పేరు కదా సెకండ్ మనం వీళ్ళు మొత్తం వేస్తే అంటే మనం సంగ పెట్టుకున్నాను మీరు కట్టించాల్సిందే మీ ఇద్దరు కూర్చొని జుట్టు కాలు పెట్టుకుని పీక్కుంటా ఇద్దరు కలిసి కట్టించాల్సింది ఏదో ఇల్లు కూడా లేకపోతే ఎవరు వచ్చినా కానీ అంతకంటే తిట్టడం తెస్తే ఏం చేయగలను నాకు కోపం తెప్పింది తప్పితే ఇంకేంటా నన్ను నేను విధించేది కాదు ఇప్పుడు ఎవరు తనంగా కాదు ఏదో ఒకటి మొదలు పెట్టుకున్నావా ఇప్పుడు ఏదో ఒకటి వచ్చిందే జరిగిందే పుణ్యం అనుకోవాలి దానికి స్టాండర్డ్ ఉంటుందా క్వాలిటీ ఉంటుందా నెగిటివ్ అది ఉంటుందా పోతుంది ఇదే జరుగుతుంది ఎవరు పెయిన్ చేయకుండా నేను చెప్పాను ఎన్ని కాదు మా అది దాని లోపల కదా నీకు బయట ఉండేది నీకు కావాలి మొత్తం పాలిష్ వస్తుంది అంటున్నాడు కదా బూట్ ఉండేది ఆ పనులు వస్తే ఏ వస్తానే ఉంటుంది ఇంకా ఆడ జరుగు ఈడ జరుగు అందుకే నేను ఒక్కరో గ్యాప్ అంటే ఒక్కరో గ్యాప్ రేపు ఎండ పెడతాను టైం ఇంకా గ్యాప్ చూసా అంటే పెయింట్ పూసేదాన్ని అవును పూసాడు రేపు ఎంత చేయాలా నువ్వు చెప్పేదే రేపు ఆ గ్యాప్ ఏం చేయాలో నువ్వు చెప్పు ఆ గ్యాప్ ఉంటుంది కదా రేపు మన త్వరలాగా పెట్టిన నేను అంటవా గుంపు ఈ బాధలు నాకు అనుకున్నప్పుడు జరిగేదాన్ని గమ్ముగా జరిగిన మంచిగా గమ్ముగా ఉండాలా ఊరికి చేయలేని ఊరికే మాట్లాడుతున్నా ఒకసారి దిగినాము ఏంటో అయింది మంచిగా జరగట్లేదు ఇవి దాన్ని పెట్టుకోకూడదని అర్థమైంది కదా వదిలేయి అడిగేది బాగా మచ్చట్లు కాదేమో ఏదో ఒక నెగిటివ్ గా తెచ్చి అడగతావా
Good morning, everyone. So, hope you all are doing well. We'll wait for a couple more minutes to let us others also join well. Okay. So we'll start the class in 2 minutes. Okay. Okay, so let's start the class. Let's start the class, guys. Okay, and let me share my screen. Mm, Okay, so ah, so in the last class we have seen this particular theoretical part of the logistic regression, how we are deriving and everything and all, and we have also learned about the confusion matrix and the performance metrics of logistic regression algorithm. Okay, I hope you all remember that. And uh, in this particular logistic regression, regression, guys, now in this 3 days session, we will be learning about the practical or implementation of this logistic regression entirely. We see the end to end. Okay, and then we okay, we divide the sessions like this. Okay, so today what we will do is the first one we will be learning about the implementation of logistic regression. Okay, and next we will see the performance metric, everything end to end implementation of logistic regression algorithm of a customer churn. Okay, we will see what are the pre-processing steps. We will take different kind of data set now, and we will see how to handle those if you get those kind of data sets. Okay, next what we will do is we will take uh, we will learn about the artificial AI part, artificial neural networks. Okay, artificial neural networks. We will learn what are artificial neural networks, what are layers present in it, what are the hidden layers, what are the outer layers, and how many layers we need to go with, or how many neurons we need to use it. The introduction part of the neural networks, how it is being evolved, and everything we will learn the theoretical concepts of this neural network tomorrow. Okay, and on Saturday we will see how we can implement, or we will see the basics of TensorFlow and Keras. We can also do the same thing with the neural networks with the scikit-learn package, but anyhow we need to learn the TensorFlow and Keras for the CNN algorithm for image classifications working with the images. Okay, so for that case we will do the neural networks with the TensorFlow and Keras. We will create a small architecture, layers of architecture. Okay, and we will run the same logistic regression algorithm what we have done, uh, what we are doing today. We will apply that. Okay, so that application part we'll be seeing in the next week, but these 3 days we will be focusing on these things. Implementation of the logistic regression algorithm today we will see. Tomorrow we will see the introduction part of the artificial neural networks and all. Okay, and then we will focus on the basics of how to install the TensorFlow and Keras, and how to configure it, and how to create small layers, what functions are involved in that. Okay, we will see that, and in neural network mathematical formulation, everything we will see. So is that clear, guys? What's our agenda for these 3 days? Yes, Venkat Raj Kumar, Bhavya, Swati. Guys, you there?
కార్తికేయన్ గ్రూప్ లో మెసేజ్ పెట్టారు కదా, చూసారా?
Okay.
మనం ఎట్లా అర్థం చేసుకుంటాం? అంతా కంప్లీట్ చేయకపోతా నేనైతే అలానే అర్థం చేసుకుంటా. తను తను డ్రాయింగ్స్ పర్స్పెక్టివ్ లో చెప్పాడంట.
Okay. So what we'll do is I have the Jupyter notebook. Let me open that
అన్ని కంప్లీట్ అయ్యాయి.
for the logistic regression. Okay. So I will share this one with you people. I will share this one with you people. This entire part. Okay, entire thing in a PDF document. I will share. You can go through it and you can check this particular one. It's a very simple logistic regression. Okay, I have prepared the notes as well for this. Because you will be working very less on the linear regression, but logistic regression is a kind of like important in any aspect of the applications. Okay, the classification part is very important rather than the predicting the actual values. Okay, so that's the reason. Second. Okay, so see, we know that let's go back to the basic things of this linear regression or logistic regression. Okay, so we know the formula of this logistic regression. Okay, here we have used theta 0, theta 1, like that. So you can ignore this theta 0 and theta 1. Okay, sorry, theta 0. Thetas you can ignore basically. Okay, theta represents B. Okay, you can, let me change it or else. Okay, you can write like this B here. Okay, B0, B1, B2, B3, like that you can do. Okay, like that you can simply modify it basically. Okay, so beta naught plus beta 1 x1 plus beta 2 x2 plus so on, like that it will go. Okay, this is a simple formula for the linear regression. Okay, and in the last class we have seen the derivation part of the entire thing. Okay, so at the end you will be getting this formula. You will be getting this formula, which is the sigmoid one. Okay, e to the power of z divided by 1 plus e to the power of z. Okay, so like that you will be getting this one. This is how the regression line will be, and above the regression line you will be having the classification of one type, and below the regression line you will be having the classification of another type. Okay, so that's how this regression, this is the sigmoid curve. Okay, that's how this sigmoid curve will give you the result basically, or it will bifurcate both the things. Okay, or classify both the classes. Okay, so that's the thing. And here, as mentioned, we'll be taking a threshold of 0.5. Your wish, you can take any threshold value. If you want to take the 0.5, or if you want to take 0.43 or something, you can take that particular part. Okay, so anything is valid. It's your wish how you want to what threshold you want to use, but generally we will be using the threshold of 0.5. Whatever the values which are present above 0.5 are classified as one class, below the things are classified as another class. That's it.
మనం మాట్లాడకుండా గమ్ము ఉంటావా ఉండవా?
Okay, now Now, so what we are doing here is we took an let me okay, customer churn data is not there. 1 minute, guys. Let me connect to my thing.
ఎవరో నీవయ్యా నువ్వు అంటే లెక్కలేస్తాను ఇంకా నీకు ముందు చూపాను చూపేయంలే ఆ రోజు ఆ రోజు నా రోజు రోజు ఈ మూల్యం కట్టుకుంటున్నాను ప్యాచ్ రీప్లేస్ చాలా ప్యాచ్ ఇస్తారు కదా పాస్పోర్ట్లో అది చాలా అంటే తను కూడా అడిగాను ఇంతకు ముందు కానీ ఇప్పుడు రిప్లై ఇచ్చాడు దాంట్లో చాలా
Okay, so this is my data. Okay, now if you check this data, okay, I didn't run this. Okay, so what this particular data is, this is like it's a telecommunication company data. Okay, so what you are doing in this company data is churn means moving out of the subscription. For example, you are having Jio and Airtel. Okay, we are having these two telecom companies. Okay, so you took the subscription of the Jio, and due to some reasons you didn't like the service of the Jio. Okay, what you will do, you will opt moving out to the Airtel. Okay, you opt to go to the Airtel company. Okay, so what the Geo companies will do is, based on your feedbacks and based on your usage in the network, so what they will do, they will analyze your behavior. Okay, based on your behavior they will give you some offers. Like if you are willing to move out of their subscription area, out of their zone, then what they will do, they will give you some offers and they will grab your attention, and they will make you consistent in that particular subscription. Okay, they will make you to continue the subscription. Okay, what's the pop-up I have got? Okay, so that's what the customer churn. We are predicting whoever the customers are moving, are willing to move, or about to move out of the subscription zone. Okay, so that's what the company need to understand, who is leaving. Okay, so for this we are going to use the pandas, numpy. Okay, so scipy optimize, we will see why we are using the optimize. Okay, so and then we are using the scikit-learn pre-processing as of now here. Okay, and then matplotlib dot pyplot plotting things we are using. Okay, now so you can go through the data set. Let's go through the data set. You just walk through these things, whichever it is written here. Okay, so let's look into the data set. Okay, see, there are many columns. There are 28 columns we are having. Okay, 28 columns. Okay, what is the tenure, what is the age of the subscriber, and what is the address. They have her address, they have given the 7, 12, 9, some ratings they have given. Okay, and what is the income of that particular one, whether he is an employee rating or not, equipped call card or not, wireless or wired he is using. Okay, so what kind of thing, all the details are present in this, or 28 columns are there. Okay, based on this, the char is the target variable. Churn is the target variable. Okay, please remember that our churn is the target variable, and rest of the things are our sorry, the rest of the things are the uh, dependent variables, sorry, independent variables. Okay, or features, you can consider them as. Okay, so now what we are doing is we are only selecting the things which are required for the processing of the algorithm. Okay, so see, if you see here, there are many columns. Okay, churn data frame dot. So if you see the columns, there are many columns here. Okay, so out of these columns, we are using only these things. We are using the tenure, age, and address rating. What is his income? What is the education? What is the employment? What is the equipment he is using? Okay, what is the call card, wireless, and the channel, and the rest of the thing we are not using. Okay, so pager he is having. Most of the people want to use the pager nowadays, and internet. We are not going to get all these things details. Okay, so only these columns we are using. Okay, and this churn data type, what we are doing for this churn data type is we are converting the churn data type to the integer part. Okay, why? Because it is in the float thing, 1.0. Okay, it is in the float. We are converting to the integer using the as type. Okay, now if you see here, sorry, okay, why this is warning? Okay, no problem, you can ignore this. This is the thing. Okay, so you have connected that churn from float to the integer part, and we are using only these columns. Only these columns we are using. Okay, now if you look into the shape of this particular one, okay, it's a 200 by 10 columns. The data set rows are very small. It's only 200 rows you are having, and the 10 columns. Okay, so then you can ignore these things, or you are taking X. Okay, see, you are taking these columns in the X, and the rest of the thing is in the Y. I mean the churn, which is the target variable, you are making it as Y. Okay, the target variable, you are making it as Y. That's what you are doing, and rest of the things are you are storing in the X variable. Okay, so you can ignore this part. This is just for printing those 5 rows, first 5 rows. That's it. You can ignore this. You can ignore this. Okay, here I'm not checking any of the NANs and filling the things and finding out the out outliers because we have already discussed that you need to do. I think I haven't written. Uh, okay, I will write this one. Sorry. Check for outliers and check for NANs. Okay, and impute them. Your mean imputation or median or standard deviation, whatever you want to do. Okay, check the distributions as well. Okay, so this is your homework. Okay, so in that the first one I have done and the rest of the three you need to do. Okay, next what we are doing, we are standardizing it. Okay, so I hope why we are doing this standardization. Okay, why we are using the station is, see, standardization, if you see them, it is in tens place. Sorry guys, so if you see here, tenure is in the tens places, digits are in tens places, address are in tens places. If you see the income can be in 100 place, 1000 place, or 10,000 place. Okay, so if you change, if you see here, it is only one's place, equip, card, wireless, chair are on one's place. This employee is in a 2-digit 10 space. Okay, so if you do this, if you directly apply, I'm not saying that you cannot do, you cannot apply the logistic regression algorithm without this standardization. Okay, you can apply, but the log, whatever the log things you are getting, right, the or log loss, or the error, whatever you are getting the error, it will be very high error. Okay, you don't know that, you can't able to imagine that that particular error is an what we call okay, so the particular error is an applicable error or not. Okay, if the error is too high, by looking into the error, what we will see that the error is very high. If it is a 3-digit error like 769, it's a very high error. What will we do? You try to reduce that error by doing some other pre-processing techniques and all, why you are getting that error. So that is the reason why we are doing the standardization. If all the things follow in the same thing, okay, in a standard or in the standard thing without any loss of any information, okay, then the error will also be very small. Okay, so that's the thing. So to over explode the error, in order to avoid the over exploding of the error, we do the standardization. We do this standardization. Okay, it's a simple thing. You are not doing anything here. You are just importing the pre-processing from the scikit-learn, sklearn. Okay, in the pre-processing you are having the standard scalar, you are fitting that x value and then transform. Okay, that's it. These three parts you need to remember: standard scalar dot fit dot transform. Any questions guys here, till here? Do you have any questions till here? Yes, guys. You hear me? Jyotika, Naveen, Kumaresh, you there? Swati. Okay. What about the others, guys? Okay. Okay. Cool. Now, next, what we are doing here, we are just training the data set. We are training the data set. So in the last class as well, we have used the test train split from the scikit-learn package, right? Here also we are doing the same thing. Okay. So we are just splitting, we are just importing the test train split from the model selection of the scikit-learn. From the model selection of scikit-learn, we are just importing the test train split. To the test train split, we are taking the x, y, and we are taking the test size here. Instead of the test size, you can also go with the train size. Okay, 0.8. In the last class, we have seen about the train size, okay, of 0.8. Here, what we are doing here, we are taking test size. Okay, test size as 0.2. Both are same. Either you can use the train size as 0.8, test size as 0.2. Okay, why? Because see, if you take the train size, equal to 0.2. Okay, so if you take the train size as 0.8, automatically what this train test split will do is it will take the test size as 0.2. Okay, why? Because both should be 100%. 8 means 80%, 2 means 20%. Both together should be 100%. If you give the test size as 0.2, automatically the train size will take 0.8. Okay, train size automatically it will take the 0.8 by default. So anyone you can give the value, anyone you can mention basically. And we are using the random state. We have clearly understood about this random state in the last class, why we use that. If you don't use the random state, every time you run this particular model, it will give you the different results basically. Okay, different set of results it will give. So to avoid that particular one, we will give the random state as 4. Okay, so any constant value you can give. It's not the thing that only 4 you need to give. You can give any random. You can give any value, random value, but that should be an integer value. And here I am just printing out the train set and the test set and its shape. Okay, see. So train is been 160 and the test is the 40. 40 rows you are having, basically. That's the part. Next, we will apply the logistic regression. The same way how you have used the linear regression model for the scikit-learn package, here also you will be having a function for the logistic regression in the linear models. Okay, if you see here, we are importing the logistic regression. Earlier we used the linear regression. Here logistic regression from the linear models in scikit-learn. Okay, we are just importing it and we are doing it. Next, confusion matrix we have seen in the last class, that box true positive, true negative, false positive, false negative. Okay, there is no need of doing all those things manually as well. Okay, if you want to do manually, you can do using that particular formula, but here it's not necessary. Basically, here you are having everything. Okay, just you need to import the confusion matrix from the metrics of the scikit-learn package and you are ready to use. Okay, now after importing these two functions, what we are using the linear regression. Okay, so this particular linear regression, we are taking the constant value as 0.01 c value. Okay, by default it will take 0.0001. With that, what it will happen is the learning rate will become very slow. Okay, so for that, what we'll do, we will give a bit more learning rate, which is a 0.01. And then the solver, what solver you will be taking. Okay, you can take, there are many solvers. For example, see, sorry. Why am I not getting this? Okay, so if you see the documentation of this logistic regression, guys, see, BDP is, see, solver. Okay, in the solver, it supports LBF GS, LIB linear, okay, Newton CG, Newton Cholesky, and Saga. Okay, default is IBFGS. This is the one. Not able to. Sorry, guys. Okay, so default is this one. So what does all these are the kinds of linear regression algorithms, guys. Okay, all these are the different linear regression algorithms. So different kind of implementations will work a different way. Okay, see, for small data sets you can go with the liblinear. Okay, whereas the SAG and Saga, these are the faster for larger data sets. Okay, since we are having the number of rows as only 200, So what we are doing? We are taking the lib linear. Okay, if you are having the larger data sets, you can go with this. Okay, for multi-class problems, you need to use only these things. Okay, linear array is limited to the one versus rest schema, means binary classification. Okay, so Newton Tchaikovsky, what's the feature of this one? If the number of samples, nothing but number of rows, okay, number of rows are greater than number of features, okay, then you can go with the Newton. So all these are the things you can use the things. And if you see the C, see what does the C give you? It will give you the regularization strength. Okay, the default value is 1. Okay, so if you give the smaller value specifies the stronger regularization. Okay, means you are regularizing the data you have given while doing the classification part. Same as the standardization. Okay.
ನಿಮ್ಮ ఇంటి దగ్గర పైపు మోటార్
That's the thing here. Sorry. And this. Okay, so you can refer the it will accept many what we call parameters, but we are not using all those parameters. Most of the parameters are the default parameters. Okay, so it's not needed to give all the parameters. Whatever the necessary parameters you want to use, you can give them, or else you can remove these also. It's not necessary. Okay, you can simply ignore this. Okay, you can remove this as well and you can run. Okay, by default the model will pick the default values and it will do the work. Okay, so only for our thing. So logistic regression object is been defined. Next, what we are doing? Next, we are passing the test cases. Okay, next we are passing the test cases. Okay, this is the predicted values. Y hat is nothing but the predicted values. So once we get the predicted values, guys, once we get the predicted values, let me run this. See, it will give you in the zeros and ones. Okay, why? Because the default nature what we have given, default threshold we have given as 0.5. Where you are getting that 0.5, I think that you will have here. Okay, it's not present. I think it is been removed from the older version. I guess earlier we used to give the threshold, but here if you want to have your own threshold, you need to predict probabilities. Okay, see how you can predict only the probabilities. See, LR dot predict proba. Okay, what it will do is it will predict only the probability values. It will predict and give only the probability values. Okay, it won't give these final classified zeros and ones. Okay, it will give you only the probabilities. This is the success probability and this is the failure probability. Like this, it will give. First one is a success and next one is the failure. This one is the success, this one is the failure. Sorry. First one is the failure. This one is failure. This one is success. This one is success. Sorry, failure, success. So first one is the failure. This one is the success. This one is for 0 and this one is for 1. Like that it will give. And if you see here, this particular thing, for the failure, we are having only 0.41. And for success, we are having 0.58. Okay, that's why we have got 1. Okay, so in both the cases, if you want to fetch, you can do. If you want to if you want to give your own probability values, or if you want to give your own threshold values, then you can go with the this probability, predict the probability, and from here fetch the values. If in this case, if it is greater than 0.7, then mark it as failure. If it is not there, then mark it as -1. Understood, guys? Okay. Manually also you can do, or else if you want to do directly with the threshold of 0.5 by default, okay, you can use this predict. Or if you don't want, you can go with the proba and define your own this thing. Next, see here. Okay, I have written here. This will give you the probability. Okay, and one more thing I have mixed about the Jacquard index. Okay, so Jacquard index is an evaluation metric. It is also one of the evaluation metrics for the accuracy, how much accurate the model is been performing. Okay, so Jacquard index give you the information. So there is no need of doing all the part. Okay, what you can do is you can simply implement the Jacquard. Is it removed? Yes, Jacquard index has been removed from the newer version, from the scikit-learn 1.4.1 version. It's having in the older version. Okay, I think it's been outdated. That indexing has been outdated. So okay, no worries. But for the same for the knowledge purpose, you just remember that the Jacquard which you have learned in the mathematics, okay, in your BTech. So the same Jacquard, okay, the same Jacquard, uh, based on his similarity for finding out the coefficients of the rank in the index of a matrix. Okay, so based on that, it will do the calculation and it will give you the accuracy, the score between zeros and one, between 0 and 1. Okay, so the value, if it is closer to 1, then it means it is having the higher accuracy. If it is very close to 0, then it means that it is having the least accuracy. Okay, like that you can assume. And guys, coming to the confusion matrix. It has to show the map, right? It is not showing. One minute, guys. If you run it, it is giving me the confusion matrix. It is giving me the confusion matrix here, but it has to plot the graph as well. Uh, Okay. Okay, so I will explain this one. First, let me plot this confusion matrix. Okay, so now see, here I'm calling the function of the confusion matrix. Okay, so what happening here, I am just using this confusion matrix from the matrix of this sklearn. Okay, from the matrix of the sklearn, I am just importing that one, and the classification report I am reporting. What I am doing, I am just creating a function here which will plot the confusion matrix. Why? Because there is no solution or there is no function in scikit-learn package to plot like this kind of graph. To plot like this kind of graph. Okay, see here, this one is the true positives, true negatives, false positives, false negatives, like that kind of thing. Okay, so we are taking this particular function to normalize the everything, and we are just plotting. Okay, title, what is the color bar we are taking, and we are taking the ticks are nothing but these lines. See, this one and this one. Okay, so you can directly use this function wherever you want, and just you need to pass these values, confusion matrix, what are the classes are there, if you want the normalization or not, what is the title of it. Okay, so call it and just pass the confusion matrix here. This is the confusion matrix. Pass the confusion matrix and it will plot you this confusion matrix graph. Okay, so whatever the algorithm you are using, either it may be this logistic regression or logistic regression, decision trees, random forest, SVM, any algorithm you take, confusion matrix you need to plot. Okay, and there are many snippets and functions in the internet available. You can use those snippets directly to plot this confusion matrix. Okay, and then in the matrix also we are having the classification report. Okay, what this classification report will do is it will give you the precision, recall, what is the F1 score and what is the support, and what is the accuracy. Precision is this, recall is this much, F1 score is this one, support is this much. Okay, so the highest the value of precision and recall, the more accuracy. Okay, now if you see the accuracy here, macro average, what it is doing the performance here, it is giving you the 0.7 of accuracy. Weighted average it is giving to nearly same. This macro average and the weighted average is giving you the nearly same, the precision. Okay, so always remember that the precision plays a major role in the classification report. Okay, precision will always play a major role in the classification report. Okay, how much precise the model is being performed. Okay, so that what the information it will give you, how much precision, how much precise the model is been performing. So for the precision, we have got an average accuracy of 0.71 and the weightage of and the weighted accuracy of 0.70. Since it is a mathematical algorithm, okay, just we need to apply the formula there, and the weights won't get directly altered or directly it will get changed. Okay, so based on the formula, it will just apply it, and there is no epochs here. Okay, so this is the value is the fixed that you need to remember for the logistic. But coming to the neural networks, what it will do is over the iterations. Here there are no iterations, just you apply that particular formula onto your data setter. That's it. That's it you are doing here. But in neural network, what it will do is it will do the prediction. It will check the accuracy. If the accuracy is very less, again it go back. Again it learns something. Again it will predict. Again it will check the accuracy. Again, if the accuracy is very less, again go back, measure the accuracy. Okay. If the accuracy is less, again learn something new, update the model. So it will do on its own. It will do on its own. Okay, in the neural networks. But here, in this logistic regression, linear regression, it is just the mathematical formula you are just applying onto it. You are not doing a much thing in that. You are just applying the formula. Okay, it's a single run, but the neural networks are the multiple runs till you will get the better accuracy or desired accuracy. Okay, that's the thing. And the log loss is not that much thing. Okay, so the loss factor it has given 0.56. This much of loss you have got accumulated, so you need to cover it up. Always remember that loss should be 0. It is 0.5, means 56% nearly. Okay, you need to bring that to the 10% or 0.1, 0.2, like that. Okay. Okay, guys, I will share this document with you people. Okay, you can get this one document for this linear regression. With this, I will also share another logistic regression, this one and another one. Go through both of those documents. You open this Jupyter notebooks and then run. Proper notes has been given there. Just follow the notes. Okay, and try to understand about the logistic regression. Okay, guys, any questions? Any doubts, any questions, guys? Naveen, okay, what about the others? Bhavya, Swati, Jyotika. Okay, so if you are not having any doubts, guys, you can drop off. I will share these notes with you people. Okay. In the meanwhile, uh, we'll meet tomorrow and we'll go into the introduction to the artificial neural networks, AI part. Okay, we'll meet tomorrow, guys. Then.
Recording stop.